Hello guys, so today we are here to solve this minimum number of vertices to reach all nodes problem. This is today's 18th May challenge, which we are here to solve. And it's a problem on graph. And graph is one such data structures which, many companies of this world are based on this graph data structure. So as a software developer, first and foremost thing that all of us need to do is to become familiar with graphs as a back of your hand. you know get as familiar with graphs as you are familiar with your back with the back of your hand. So that is one thing which we all should be knowing this thing. And so let's start understanding this problem first, then we'll look into how to solve this problem. So in this problem, we are given a directed acyclic graph. So first thing that we need to notice here that we have been given a directed graph. And in this directed graph, the edges are, acyclic. It's a directed graph. And then there is no cycle in this graph. So that's why this has been called as directed acyclic graph or DAG. Okay. With n vertices. So this n vertices will be given to us numbered from 0 to n minus 1 and an array of edges. Okay. So an edge I is, will be having two ends, the from end and then the end, another end, which is the to end. Since it's a directed graph, so there will be an edge from the first vertex to the second vertex, the end vertex. Okay. And then we need to find the smallest set of vertices from which all the nodes in the graph are reachable. So we have been given this adjacency list. Okay. Adjacency list will be, telling that which one is the first vertex and which one is the second vertex, the end vertex. And there will be several such components, as many components as there are edges in the graph. Okay. And then there are six number of, total six number of vertices, which will be, initially given to us. It will be passed as parameter to us in the method call. And what we need to return back is the number of total vertices which doesn't have any, for which there are no incoming edges. Okay. Okay. And from those, we have to, we can, cover the whole graph. So from those vertices. So I know, this explanation is not sufficient, but if you have any doubt, please post it in the comments. I want us to, have discussion over these things in the chat, and we can make it as lively as possible. I'll definitely answer those concerns. So it will be better, if we understand this thing with a example, then it will be, better understood. So with this, let me, try to explain. In this, we are given, this graph, and in this graph, we have been, in this graph, we have several vertices and several edges. But if you notice that if we start from 3, we can go to 4, then we can go to 2, and then we can go to 5. From 2, we cannot go to 0 because the direction of the edge is from 0 to 2, not from 2 to 0. So from 3, we can cover this component, only this component. But if we take a start from 0, then we can go to 1 and then again go to 2. So from 0, we can cover these components. So we need to return back the list of those vertices from which we can reach the graph. So see, if we start from 1, then we'll not be able to reach anywhere. Okay. So that is of no use. So only places from where we can start and reach cover whole of the graph are 3 and 0. So 3 and 0 are the two edges. Okay. Now with this understanding, we will try to solve this problem. So since this is a graph problem, many people will think that, this might require DFS or topological sort or BFS or Kruskal algorithm or whatnot, Prim's algorithm. So many algorithms are there, and, Kahn's algorithm, what name it, and, graphs admit a large variety of algorithms. But my solution, which I'm going to show you, is not based on, these typical algorithms. Of course, you can make use of them and, make this problem even easier to solve. But I would suggest that, instead of thinking along those directions, let's first, try to understand the problem, and then let's break it up. So now what we'll do, that we'll create one, Boolean array, bool array, and the Boolean array is going to have n elements, and then what we will do, that we will do for list of integer L edges. So for each list in the edges, so edges consists of list, and edge is a list of list. So for each list of integer in the edges list, what we will do, that we will, do bool ar L dot get 0 is equal to true, 0 is equal to true, is equal to true. Okay. And then what we will do, that we will have okay. Now what we will do, that we will, try to um, we have this now. Okay, so what we can do now, so for int I is equal to 0, I less than n plus I. So now we have marked all those, in the previous step, we have marked all the values which has, so we should mark the, second edge. Okay, second edge should be yeah, so we have marked the second edge as true. So it means that for these edges, there are incoming. For these vertices, for these vertices, there are incoming edges. For these vertices, there are incoming edges. Okay, so, and the rest of them. So we can say that if bool array of I, so if something is false, so if something is false means negation of false is true, then what we'll do, that we will, create one list. Let's create one list. Okay, and in this list we'll be adding result dot add I. Okay, and then we'll run it. Perfect. So this solves our problem. So if you see, nowhere we have used, nowhere we have used depth first search or any such algorithm. We have just plain simple logic, and that's how we have solved it. Can we do better? I think we can do better. Is it possible that, yeah, yeah, this is the best. With this approach, this is the best that we can do. So let me know if you have any doubt. I'll be happily answering your doubts and questions. So with that, I'll, close this solution video. If you have any doubt, any other questions regarding anything on data structures algorithm, feel free to post it on the comments of this video. I'll be happily, answering them. Thanks a lot.